Hello and welcome to Algebra 1 Lesson 58. In this video, we're going to learn about solving equations with radicals. So a radical equation is an equation where there is a variable in the radicand. So let me repeat that. A radical equation is an equation where there is a variable in the radicand. So I know most of you know this, but in case you don't, because you might be saying, what's a radicand? Again, if we had something like a square root or a cube root or fourth root or whatever it is, let's just go with a square root because that's the most common. The radicand is the number or the variable or the, you could say, expression that's underneath that symbol. So something like square root of 3x. This would be your radicand. So again, a radical equation, one more time, is an equation where there is a variable in the radicand. So as an example, we see something like the square root of x plus 2 equals 5. In your radicand, you have that variable x. As another example, we have 4 times the square root of x is equal to 2x minus 3. Here, the radicand just consists of x, but that's a variable, and so this is a radical equation. All right, so in order to solve a radical equation, we need to introduce a new property of equality known as the squaring property of equality. Okay? We've also learned, the addition property of equality and the multiplication property of equality. So this is just another tool in our chest, to solve equations moving forward. So the squaring property of equality, there's one kind of little hiccup to this thing. When both sides of an equation are squared, all solutions to the original equation are among the solutions to the squared equation. Now, that seems like it's not a big deal, but it really kind of is. If I use something like the addition property of equality, as we recall, that looks like this. Let me kind of scroll down. We have x plus 2 equals 4 as an example. I know the solution to this equation is x equals 2. If I added 3 to both sides of the equation, so let's say I add 3 over here, that would make this 5. I add 3 over here, that would make this 7. The solution is still x equals 2. Still works out. If I have the multiplication property of equality, so something like, let's say, 3x equals 12. I know this is x equals 4. If I multiply both sides by negative 2, this would be negative 6x, and this would be negative 24. X equals 4 is still a solution. Plug in a 4 there, you get a true statement. With the squaring property of equality, this is not always going to be true. So let's suppose we had x equals 3. Very, very simple. I know that if I replace x with 3, I get a true statement. But let's say I square both sides of this. So x becomes squared and 3 becomes squared. So now I have x squared equals 9. Now we haven't covered how to solve an equation like this yet, but let's just think about it. It's a very, very simple equation, so we can kind of, mentally figure out what this is. What squared would give me 9? Well, I know 3 does, right? 3 squared would be 9. 3 times 3 is 9. But I also know that negative 3 squared would give me 9 as well. So the solution for this equation would be x equals 3 or x equals negative 3. So there's 2 solutions there. But in the original equation, if I took this negative 3 and I plugged it in for x here, we'd have a big problem. We'd have negative 3 is equal to 3. That's false. That does not work. So let me kind of line this out and say wrong. Okay, that's wrong. So you can see that when we squared that equation, we came up with an equation that had solutions that did not work in the original one. So that's why it's very, very important that when you use the squaring property of equality, you have to check each and every solution that you generate in order to make sure it works in the original equation. All right, so now let's just take a look at the procedure to solve a radical equation. So I have Solving a radical equation, we want to isolate the radical. So that's the first thing you're going to do. Now, in the most complicated situations, you're going to have more than one radical involved. And in that case, you just want to isolate one radical at a time. Now, the next step is going to depend on what type of root you're looking at. Do you have a square root? Do you have a cube root? Do you have a fourth root? In Algebra 1, we're just going to deal with square roots. So I just put square both sides. So we would square both sides in the case of a square root. Then we would combine any like terms. Now, at this point, if you had any radicals that remained, you're going to go back up to this first step and you're going to come back down. You're going to keep doing that until you're radical free. Then lastly, you're going to solve the equation and check all potential solutions in the original equation. Okay? And again, this is very, very important. Check all potential solutions in the original equation. It's not going to happen to you every time, but at least sometimes the solutions you're going to get from that transformed equation is going to give you problems or not work in that original one. And so it's not going to be a solution that you can use as an answer for your problem. All right, let's start out with something very, very easy. So we have the square root of n is equal to 3. So the radical is already isolated here. Okay, so I don't need to do that step. And I would just start out by just squaring both sides. So if I have the square root of n is equal to 3, and I square this side, and I square this side, what's going to happen is we know that this cancels with this, and I just have n, and 3 squared is 9. So n equals 9. I get one solution there. So plug this back in for n. If I plugged in a 9 there, what would I have? I would have the principal square root of 9 is equal to 3, and that is true, right? Square root of 9 is 3, you get 3 equals 3. So this checks out as a solution. Let's take a look at another easy one. So we have that the square root of x is equal to 5. Again, the radical is already isolated for me. I don't need to do that. And so all I need to do is just square both sides of the equation. And so what's that going to give me? Well, this is going to cancel with this, and I'll just have x. 5 squared is 25. I get one solution only. And so again, if I plugged in a 25 for x there, the square root of 25, we all know that's 5. So this is a valid solution. Let's look at one that's a little bit more challenging. So we have the square root of 15p minus 56 is equal to p. So the radical, again, is isolated for me. So what I'm going to do is I'm going to, again, square both sides. This equals p. So I'm going to square this side, and I'm going to square this side. Okay. So if I square this, this cancels with this, and I'm left with the radicand. So I'm left with 15p minus 56, and this equals p squared. So what we have now is a quadratic equation. And we've worked with these in a previous lesson, and I taught you how to solve them when they're factorable. We have not gotten to the point to where you have a quadratic equation, it's not factorable, you know how to solve it. We're going to get to that when we start talking about completing the square and then the quadratic formula. That's going to be the very last lessons of Algebra 1. So for this lesson, I gave you stuff that you could factor. All right, so for this, I'm just going to subtract 15p away from both sides. I'm going to add 56 to both sides. And that's going to make this side equal to 0. So what I'm going to have, let me scroll down here a little bit. And I like 0 to be on the right side. So let me move everything over. So I would have p squared minus 15p plus 56 is equal to 0. And I'm going to factor my left side. Okay. So I need two integers whose sum is going to be negative 15 and whose product is 56. It's going to be negative 7 and negative 8. So minus 7 minus 8. So we know how to solve this. We take each factor, okay, that had a variable involved, we'd set it equal to 0. It's called the zero product property. Okay, so we'd have p minus 7 equals 0. And then also we can put or p minus 8 equals 0. Add 7 to both sides here, add 8 to both sides here, and we get p is equal to 7 or p is equal to 8. Now, We're not done because we need to check this in the original equation. So if I plug in a 7 for p there, I would have the square root of 15 times 7, which is 105, minus 56, and this should be equal to 7. So 105 minus 56 is 49. We know that the square root of 49 is 7, right? This would give me 7 equals 7. So that's a valid solution. For the next one, we have 8. Okay, so let's try that out. Now, this stays the same. And 15 times 8 now would give me 120. So if I do the square root of 120 minus 56, that's the square root of 64. 120 minus 56 is 64, so this would be the square root of 64 is equal to 8. And we know that's true, right? This would be 8 equals 8. So this is a valid solution as well. So here, p equals 7 or p equals 8. All right, let's take a look at another one. So we have the square root of negative 100 plus 20x is equal to x. This is already isolated for us, so let's go ahead and just go into the step where we square both sides. So negative 100 plus 20x is equal to x. So I'm going to square this side, and I'm going to square this side. So this is going to cancel with this, and I'll just have this. I'll have negative 100 plus 20x is equal to x squared. Again, I'm going to set this up by just putting everything on one side and setting it equal to 0. So let me add 100 to both sides. And let me subtract 20x away from each side. So that's going to be gone and be equal to 0. And I like my 0 to be on the right, and I like everything else to be on the left. So let's just rewrite it as x squared minus 20x plus 100 is equal to 0. Okay, so now that that's set up, again, I gave you stuff that you could factor. So let's go ahead and factor this guy. We'll have x here and here, and then give me two integers whose sum is negative 20 and whose product is 100. So we know that's going to be a negative and a negative, right? Negative times negative is positive, negative plus negative is negative. So if I think about this, I could do negative 10 and negative 10. Negative 10 and negative 10. I know that this would only have one solution, right? Because it's basically x minus 10 as one factor and x minus 10 as the other factor. So this would be one solution of x equals 10. So let's check this out in the original equation. Okay, so if I have square root of negative 100 plus 20 times 10, 20 times 10 is what? That's 200. This should equal 10. Let me kind of scooch this out of the way. That over there. Okay, so if I simplify this, negative 100 plus 200 is 100. So I'd have the square root of 100 equals 10. And that's true, right? You get 10 equals 10. So yes, this is a valid solution. X equals 10. All right, let's take a look at another one. So now we have negative b plus the square root of 6b minus 2, and this equals 1. So notice how this is not isolated, okay? The radical is not isolated. So we're getting into some more challenging problems, really just more tedious. So I can't just go ahead and start squaring things, right? I can't square both sides. That's going to be really, really sloppy if I do that. So what I want to do, again, I want to isolate the radical. So I'm just going to add b to both sides of the equation. And I'm going to end up with the square root of 6b minus 2 is equal to 1 plus b. Now, if I square both sides of the equation, I'm going to get rid of the radical. So this is going to cancel with this, and I'm going to have 6b minus 2. And remember, this has to be expanded. I can't do that common mistake where I just go, okay, this is 1 squared plus b squared. We've covered that many, many times, and at this point in Algebra 1, you should realize this needs to be expanded. Now, fortunately for us, we know the formula for this to do it very quickly. It's this guy squared plus 2 times this guy times this guy plus this last guy squared. So really, it's b squared plus 2b plus 1. Let's rewrite that. b squared plus 2b plus 1. Let's scroll down a little bit. Get some room going. And let's add 2 to both sides of the equation. So that's gone. And let's subtract 6b away from each side of the equation. So that's gone. So I would have 0 over here on the left is equal to, we have b squared minus 4b plus 3. And let me just kind of switch this around and say, okay, I have b squared minus 4b plus 3 equals 0. And again, that's just personal preference. You don't have to do that. It's just up to you. Okay, so now what I want to do is factor the left side. So this is going to be factored and equal to 0. And I know the first terms would be b and b. So now I need to find two integers whose sum is -4 and whose product is 3. So I know this has to be a negative and a negative, right? Because negative times negative is positive. Negative plus negative is negative. It's easy because 3 is a prime number, right? It's only 1 times 3, so it has to be 3 and 1, right? So b minus 3, that quantity, times b minus 1, that quantity. So to solve this, again, use the zero product property. We're going to set each factor with a variable equal to 0. So we'd have b minus 3 equals 0, or b minus 1 equals 0. We'd add 3 to each side of the equation here. We'd add 1 to each side of the equation here. And what we're going to end up with is b is equal to 3, or b is equal to 1. All right, so let's check this. And we had b is equal to 3, or b is equal to 1. All right, so let's start out with b equals 3. So let's plug in a 3 here and here and see if we get a true statement. So we would have -3 plus the square root of 6 times 3 is 18 minus 2. So we know we can just replace that with 16. And this should be equal to 1. Square root of 16 is 4. So I'd have -3 plus 4. That is 1. You get 1 equals 1. So yes, this is a valid solution. All right, for the next one, I'd replace my b with a 1. So I'd have -1 plus the square root of 6 times 1, which is 6, minus 2, which would give me 4. So the square root of 4, and this should be equal to 1. Now the square root of 4 is 2, so I'd have -1 plus 2. That gives me 1, and that equals 1. So we get 1 equals 1. Again, this solution is valid. b equals 1. So we have b equals 3 here, or b equals 1. Okay, for the last problem that we're going to look at in this lesson, we're going to dive into something that's much more tedious. This is a type of problem where you want to focus as much as you can because it's very, very easy in these longer problems to make a silly mistake that costs you the right answer in the end, right? The worst thing is you do all this work, you made some silly mistake, and then you go to check your answer and you're like, I made a mistake, and you have to start the problem over. So just pay close attention to the ones like this that are very, very tedious. Okay, so we have -1 is equal to the square root of 2 minus a minus the square root of -1 minus 5a. Now, up until this point, we've seen that we would square both sides after we isolated the radical, and we were radical free. In this case, we have two radicals involved, so that's not going to happen. What we have to do is isolate one radical at a time, okay, and work our way through the problem. So that's what makes this much more tedious. So let's just copy the problem. So -1 is equal to the square root of 2 minus a minus the square root of -1 minus 5a. Now I want to isolate one of these guys. Doesn't matter which one I choose. I end up with the same answer in the end. I think it would be easier for me to isolate this guy right here. And so I'm going to add the square root of -1 minus 5a to both sides. So over here, it's going to cancel itself and go away. And I'm just going to add it over here. So plus the square root of -1 minus 5a. Now, what I can do at this point is I can square both sides of the equation, and I'll get rid of one, and only one, of the radicals. So I'll have -1 plus the square root of -1 minus 5a. And I'm going to square this guy. And then this is equal to, we have the square root of 2 minus a, and I'm going to square this guy. Now, we know at this point that this would cancel with this, and I'm left with this. So I'm going to put equals 2 minus a over here. For this side, it looks like it would be kind of complex to do that. But again, we can use our special products formulas to speed up the process here. That's why we went through and memorized those. So I know for this, I would square the first guy. -1 squared is +1. So let's write that all the way down here. And then the next thing would be, we would have plus 2 times this guy times this guy. 2 times -1 is -2, so I'll write -2. Then times the square root of -1 minus 5a. Then the last thing is I want this guy squared. Well, if I squared the square root of -1 minus 5a, we again know that this would cancel with this, and I'd be left with this. So I'd have -1 minus 5a. All right, so now that that's worked out, what I want to do at this point is simplify. So when I look across, I see that I have a 1 and a -1. So those would cancel. And then I see that I have a -5a and a -a. So I can add 5a to both sides of the equation. That's going to cancel. So I'm going to have this -2 times the square root of -1 minus 5a. And this is equal to, and I'm just going to reorder this to 4a plus 2. Okay, -a plus 5a is 4a. Now, what I want to do is I want to square both sides of this equation one more time to get rid of this radical. This is going to be a little bit tricky, and I'm going to explain why. So let me square this side, and let me square this side. Now, when I square this guy, I want you to think back to when I squared something like a times b squared. This is equal to a squared times b squared, right? We all should agree on that. If I look at this more closely, this is really what? This is -2 times this quantity, and let me just put it in parentheses, -1 minus 5a, okay? So if I squared this, I would end up with what? Let me kind of erase this. Following that model, I'd have -2 squared times this square root of -1 minus 5a, that guy squared. Now, this will cancel with this and give me this. Where students make a mistake is you're still multiplying here. So let me kind of go through this. Let me move this down, or I'll actually move it over to get some room. And let me show you what I mean. So when this comes down, -2 squared, which I have here, would be +4. But this is still multiplying the result of this. So the result of this is the quantity -1 minus 5a, okay? The common mistake that you see is, let me just erase this. Students just go, okay, well, this is 4 minus 1 minus 5a. That's not correct. Again, if we go back to the example of a times b, and this is squared, we all should agree that this is a squared times b squared, okay? So it's the same thing here. This is squared, that's 4, times the result of this squared, which is the quantity -1 minus 5a. So you've got to make sure that you do that correctly. All right, so with that being said, let's put this is equal to, we have 4a plus 2, that quantity squared. And again, we can use our special products formulas for this. Square the first guy, that's 16a squared, plus 2 times this guy times this guy. 2 times 4 is 8. 8 times 2 is 16. Then times a. Then plus the last guy squared. All right, so simplifying here on the left, 4 times -1 is -4. And then 4 times -5a is -20a. So this equals 16a squared plus 16a plus 4. Let me scroll down. And so let me add 4 to both sides of the equation here. And let me add 20a to both sides of the equation. So this would be 0. So I'd have 0 is equal to 16a squared. 16a plus 20a is 36a. So plus 36a, and then plus 8. And again, I like the 0 on the right side. It doesn't matter. It's just personal preference. So I'm going to rewrite this as 16a squared plus 36a plus 8 equals 0. So before I move forward, I notice that I can pull a 4 out of everything. So if I pull a 4 out, this would be 4a squared plus 9a plus 2, and this is equal to 0. So to factor the inside here, I'm going to use factoring by grouping. So give me two integers whose product is 8 and whose sum is 9. That's easy. That's 8 and 1. So let's rewrite that middle term. We'll have 4a squared plus 8a plus a plus 2. This is equal to 0. Okay, so let's erase this. And let's get our little room going. So I'd write 4. In the first group, I could pull out a 4a. What would that leave me with? A plus 2. In the second group, I just pull out a 1. And that would leave me with a plus 2. Okay, so then this equals 0. And so what I'm going to do now, I'm going to factor out the common binomial factor. That's this a plus 2 here. So if I pull that out, I'd have a plus 2, that quantity, times, I'd have 4a plus 1. Okay, this equals 0. So now, in factored form, I have 4 times the quantity a plus 2 times the quantity 4a plus 1. Okay, and then this equals 0. So using my zero product property, I set each factor with a variable equal to 0. So I don't need to set 4 equal to 0. That doesn't make any sense. I'd set a plus 2 equal to 0. And it also set 4a plus 1 equal to 0. So this is easy. Subtract 2 from each side. You get a equals negative 2. For this one, I subtract 1 away from each side. I get 4a equals negative 1. I divide both sides by 4. And I get a equals negative 1/4. So a equals negative 2 or a equals negative 1/4. Now, let's go back and let's check each one and make sure that they work in the original equation. So we have a equals negative 1/4, and we have a is equal to negative 2. So let's start out with a equals negative 2. So if I plug that in, let's have negative 1 is equal to the square root of 2 minus a negative 2 is like 2 plus 2. So the square root of 4. We might as well replace that with 2. We know what that is. So we'll have a 2 there. Minus the square root of negative 1 minus 5 times negative 2 is negative 10. So I'd have minus a negative 10, which is plus 10. So really this would be 9. We know the square root of 9 is 3. 2 minus 3 is negative 1. So that one works out just fine. So this is a solution for our equation. So let's take a look at a equals negative 1/4 now. So we have negative 1 is equal to the square root of 2. We have minus a negative 1/4. That's like 2 plus 1/4. Okay? So 2 plus 1/4. Now, to deal with the fact that we have fractions involved, I could write 2 as 8/4, right? 8/4. And really, I could write this as 9/4. So the square root of 9/4. And we know we can write that as the square root of 9 over the square root of 4. Square root of 9 is 3. Square root of 4 is 2. So this is really 3/2. This is 3/2. Then minus, over here I have the square root of negative 1 minus 5 times a negative 1/4. So negative times negative is positive, so this would be positive 5/4. So plus 5/4. And of course, to get a common denominator here, I would simply write this as negative 4 over 4. Negative 4 over 4. Negative 4 plus 5 is 1. So this would be 1/4. This would be 1/4. And again, I can break this down into the square root of 1 over the square root of 4. Square root of 1 is 1. Square root of 4 is 2. So this is 1/2. This is 1/2. So 3 minus 1 is 2. And this would be over 2. 2 over 2 is equal to 1. So what do I get here? I get that negative 1 is equal to 1. That's not right. Negative 1 doesn't equal 1. And this is part of the problem, again, when you use that squaring property of equality, you're going to end up with solutions that don't work in the original equation. So this one does not work. It's not a valid solution in the original equation. Okay, this is wrong, not a true statement. And so the solution here is a equals -2, and that's your only solution.